Okay, so you do have to do a little bit of drawing as we go, filling in the blanks. I realize that some of them are going to be reviews, repeats, but I got the impression after that last lesson that we probably need to do this again just to clear some stuff. I wasn't happy. I didn't think that you guys learned anything. So we're going to try it again. Okay, so a neutral object. This is charging by contact, which is what we're going to do. There's some controversy over that, whether we're doing that today or not. Anyway, a neutral object, usually a conductor, can be charged by coming in contact with a charged object. Charge is transferred between the charged object and the neutral object. So here is the setup. Right? Blake, are you jotting these down? To get through all this, we can do the shocking experience. You're going to get zapped. Anyone with a heart condition that I need to know of? I have a brain condition too. I have a brain injury.
Me too.
Do you?
We're playing volleyball.
Well, take it with your hand, not your head.
I don't
It happens.
fight the...
Did you? Spike to the face.
Yeah.
Okay, so we've got a charged object, usually a neutral object, usually a conductor, can be charged by coming in contact with a charged object. I'm going to show you this time how that works. So charge is transferred between the charged object and the neutral object. So here I've got a positively charged rod, and I'm going to, see that? I'm going to touch the neutral copper pipe. Now, how can you tell that the positive charged rod is positive? Look at all the positive signs it has in there, right? There might be a few electrons in there, right? But overall, there's a surplus of protons. There's more protons than electrons. This guy is neutral. I symbolize that by showing just as many positives as negatives. I didn't count them, but they're pretty close, right? Okay, so it's pretty much neutral. Okay, so now when I bring in the charged rod and do this, when I touch it, what happens to the electrons that are in here? They're attracted to the positives and they go over there. So can you draw that in there? Can you show those electrons going into there and sort of being balanced out? The positive charged rod comes in contact with the pipe and the electrons begin to flow toward the rod. Does that make sense to you, that why those negative charges would do that? Why they would go over there? Okay, so now the question is, what happens when you remove the question is, what happens when you take that positive charge rod and you pull it away? When you pull it away, the rod is now less positive. Why is it less positive? We've added some negatives, right? We've added some negatives. It's only slightly positive. And what happened to the neutral copper pipe? It's now more positive. How come? Because there's more positives here. So on this one here, I want you to make sure that you've got less negatives here, more positives here. Right in rod is now less positive, pipe is now more positive. You'll need to be able to explain that on a test. I would expect you to be able to do that. I would expect you to be able to draw diagrams and explain that process. So the second one, charging by induction. This is charging without touching, and I'm going to explain this process with some better pictures, and again, hopefully with the things in order, it'll work better here for you. So a temporary induced charge. Again, the word temporary means not permanent, right? The negative charged object is brought near a neutral conductor, so I'm bringing in this negative rod here. This is neutral. It's got just as many positives as negatives. The negative charge object repels the negative charge at the end of the conductor nearest to it. So these guys that were sort of in here, grab those negatives. Oh, get out of there. No, now I can't move. These guys here that were sort of here end up where? They go to the right-hand end. Why do they go there? They're repelled by these guys. They don't like them. Does that make sense? The negative charges on that neutral rod will go to the right-hand side. They're going to move away from these negatives. Can't see?
Why are you going so fast?
This creates what we call a charge separation. What do I mean by that? See those positive and negatives? They are separated. The conductor now has a positive end and a negative end. Positive end, negative end. The presence of the negative charge object has induced or created or started a positive and negative charge on the ends of the neutral conductor. But if this negative charge is removed, if I pull this guy away, Blake, if I pull these charges away, this guy here, what are these guys going to do? They're going to rebalance, right? And the conductor will become neutral again. Okay, go ahead. If you want to make it a permanent induced charge, a permanent induced charge requires one more operation in the process you've just completed, and that extra operation is called grounding. To ground an object means to provide a conducting path between the object and the earth. Grounding by touching a charged object can be extremely dangerous. Okay, we're going to be doing very small charges, should not be a problem here. How do we ground an object? What are you really doing when you're grounding an object? You're providing a path for the electrons to either leave to the ground or come from the ground back to the object, depending on the charges. Yeah, I'm just repeating myself to make sure that people get it. The earth, the ground is giant. It's a huge reservoir. What does the word reservoir mean? Reserve or storage area, collection. Right? The earth is a huge collection of positive and negative charges, so it can easily absorb or release negative charges to an object when necessary. We're going to be learning about lightning in the near future as well. Do you think lightning is related to grounding to the earth?
Yeah.
Absolutely, right? Why do you say that, Andrew? Because it is? You just know? Well, it's certainly electricity to the earth, or from the earth to the cloud. Grounding can also be used to neutralize a charged object, which we're going to be doing as well today. You can ground objects with small electrostatic charges by touching them. We saw the video the other day of the people at the gas station, right?
Yeah.
What do they recommend you do when you get out of your car? Ground yourself by touching something, touching the pump, touching your car, touching something so that you are neutral, so that when you go and touch the nozzle, no spark, right?
Especially if you're a girl.
No, that's not true. What was the deal with the females? They found, for some reason, females tend to put the nozzle in the gas tank and then get back in the car.
Yeah, some reason they're
Why did it
happy to their
I don't know, that was kind of weird. Clearly, these are not women that are just wearing their underwear to get gas. Yeah. All right, so here we're going to talk about a permanent induced charge. Set up the apparatus, charge the neutral copper tube as shown. So, again, negative charge over here. Positive end. Negative end. Negative charge, right? Negative charge over here. Positive end. Negative end. Will that work? No, it doesn't like it. So, we're inducing that charge here, but it's just temporary. Next step, touch the copper tube with your finger. See the finger there?
How are we going to do that?
Similar, yeah. Touch the copper tube with your finger. Where do the negative charges that are at this end of the rod go? To the ground. The charges like to go to the ground. You see the little negative signs in there?
Yep.
Going for a walk along the finger? Draw in the little finger.
It's already drawn.
Oh, you have the finger. Okay. Okay, draw the negative charges in there. Notice what happens to the number of negative charges in this rod here. Less of them, right? Where do those charges go? They went to the ground. They went to the person that's touching it. They now become a superhero. They have 4 electrons in their finger. Danger. Now remove your finger from the copper tube, leaving the charged plastic straw where it is, and then take the charged plastic straw away. This is the one that was on the right. What is the charge on the tube now, after the electrons left? It's now positive. Is it permanent? Is it permanent or is it temporary? Permanent. At least until you do what? Until you touch it again. How will you know, if I could just go back for a second here, how will you know that these charges have transferred to your finger? Will you feel it?
Yes.
How will you know if you were to touch this again with your finger? How would you know that what would happen to the charges in your finger? Would they go back?
No, they're not.
Would they go back to here?
No.
Why not? Remember, this thing is now what? Positive. The charges here would be, hey, that's a positive place. I'd like to go there. They'd go back, right? That's how it works. Okay. Let's give this activity a whirl here.